Hello everyone, myself Deepa Singh, working as Assistant Professor in India School of Pharmacy, SGVU. Today we discuss about evaluation parameter of evaluation test for liquid orals. In previous lecture, we already covered liquid orals, different types of liquid orals, and their excipient that used for liquid orals and example of these excipients, formulation method, procedure. So today we discuss about last part of this liquid orals, that is evaluation parameter or quality control test for this liquid oral formulations, including syrup, elixirs, and suspension, all liquid orals. It is a topic of industrial pharmacy, one subject, 5th semester. Before starting this topic, we should know about this learning object or basic object. In this learning object, first there's brief introduction about evaluation of a liquid dosage form, means how we perform evaluation parameter and how we evaluate different quality control tests for liquid dosage form, and evaluation parameters means different tests that are used for evaluation of this liquid orals. Next is procedure of evaluation test, means how we perform this evaluation test, including the procedure. So this is the learning object. Now we start evaluation test for syrup. This is a liquid oral dosage form. We know syrup because we already discussed previous one lecture. Syrup, how we perform syrup, the excipient that used in syrup, and formulation procedure. All this we covered in previous lecture. Now we discuss about evaluation parameter of syrup or how we evaluate syrup. In this evaluation of syrup, a concentrated solution of the sugar, such as sucrose in water or other excipients or other aqueous liquids, sometimes with medicinal agent will be aided, means don't necessarily that first we know about syrup. So it's a definition of syrup. Syrup may be medicated syrup or without medicated syrup. This is mainly contain sugar solution or sucrose or any sweetening agent or sucrose. And in this, you can say that this syrup is contain water and other liquid. Aqueous liquid means maybe contain 100% liquid as water and or other aqueous liquid solution. Sometimes the medicinal agents are agent. Medicinal agent means your API and drug. So in this syrup, maybe you can add a drug or some API. It is not necessary that some drugs are present in your formulation or not. Maybe it's not a medicament. Then in this condition, syrup do not contain any API or active drug ingredient. Usually you followed as a medical vehicle for drug. Means you can also use some flavored for improving the taste of a drug or formulation of a drug. Means syrup is also contain any flavoring agents as excipient, and it is commonly expanded to include any liquid dosage form. Example, oral suspension and sweet and the SID vehicle. This is a formulation, and in this evaluation parameter for syrup, first test is transmittance of light. In transmittance of light, matter is newer tool that is used to check the syrup color. In this light transmitter, a syrup sample is checked for color by passing the light through the sample, and the percent of light transmission is compared to light transition rate set for diffraction rate. And so use one transmitter for transition of light, and this is mainly used to check the clarity or transition of your syrup solution. When you pass the light or transition light in your formulation, it form transition rate or different grades of that transition is measured, that equipment or that setup. And when using one, you need to show that are no fingerprint on the syrup test bottle, and the syrup sample has no bubbles or cloudiness. Before starting this test, because in this test you are checking transition or transparency between your formulation or how much transparent your syrup solution. So before starting this test, you should assure that there is no fingerprint on the container on your syrup bottle, and no cloudiness or no bubble is formed in your syrup or in your formulation. This should be clear without any bubble or without any cloudiness, and no fingerprint present on the surface of your container or syrup bottle. And this condition may be diminish the light that is transmitted to the sample and therefore lower grade of the sample. If this type of problem is occurring in your formulation, then during evaluation there may be chances that it diminish or show some errors in the result. You don't get accurate result or proper results of this transmission of light evaluation parameter. So this is regarding the transmission of light. Next is visual inspection. Visual inspection in itself will say that you can visualize this formulation without any instrument or without any machine. And in this visual inspection, the ingredient and final product are carefully examined. And not only final product, but during starting the formulation or during finalize the each and every excipients, you just check all ingredient, including excipients and the API, are in a good quality or are compatible with each other or their stability. And you can also examine final product of your syrup or your formulation. And for purity and appearance, physical appearance of a product for patient adherence and compliance is critical. So there's a good looking elegance in appearance. Means in this visual inspection, you are sure that your all excipients, ingredients are in a good quality and the final product is also a good quality. So you just check the appearance and purity. After this, finalizing this, that you can say that your final formulation should be also good quality due to the physical appearance easily checked. And patient adherence and compliance is also good if your formulation is a good quality and properly there. And it is a good looking and elegance in appearance. So more acceptability in market of your formulation. Next is pH measurement. This is test for your syrup. You may use the pH meter in lab scale or maybe pH instrument or measurement for this pH determination. And the measurement and maintain pH is also very important step in the quality. Means you should know the proper quality of proper pH of your formulation. And control testing channel, there's two different type of method use measurement of a pH. In this, it's a pH meter that you use for testing of a particular pH. You just dip your formulation or syrup solution in this, and with the help of this pH meter, the readings get recorded here. And this show the pH of your syrup or your formulation. In method of pH measurement, the sample is cheapest to dip a piece of pH paper into the sample. The paper is impregnated with chemical that change the color, and color may be compared to chart supplied with the paper to give a pH of the scale. This pH measurement method is mainly used in a lab scale, or it's a very simple method or very cheap method with the help of a pH paper. You just take a pH paper and dip in your syrup or your formulation. When you dip this pH paper in your formulation, it gets changed color. And what color it show or changing of that color, particular color, you observe with pH paper or pH ranges. With the help of this pH ranges, you can check how much pH of your formulation. So with the help of pH paper color change, you easily check the particular pH range of your formulation. Next is the greatest accuracy is required. A pH meter should be used. And this previous method of pH method is mainly lab scale method. It give a good result, but it's not give an accuracy result or accurate result, suppose in decimal, 7.2 or anything else. It just give a range due to that particular color. So if you require more accuracy or appropriate or exact result of pH, then in this condition you use pH meter for this pH measurement. And typical pH meter consists of a spherical measuring glass. Means you can say that the pH meter consists of a glass electrode, and that we see in previous slide and diagram. And there's a one electrode, it's a one glass electrode. You dip your syrup or your formulation in this glass electrode, and greatest accuracy in pH meter, and a typical pH meter consists of a spherical measuring glass electrode connected to an electronic meter that measure and display the pH reading. Means that glass electrode, you dip in your formulation. When you dip this in your formulation, your readings of your formulation or particular pH range is recorded in electric meter because it is connected to electric meter, and display this reading to this electric meter how much exact pH of your formulation. Next is sucrose concentration. This type of evaluation parameter test is mainly for syrup solution because it contains large amount of sugar or large amount or large concentration of the sucrose. So we check how much sucrose or how much syrup contains sucrose concentration. So in this determine the sucrose concentration, it is also very important in quality control testing of the syrup. It is the concentration of the sucrose in the syrup. This is a very high, may we crystallize the syrup, and less sucrose concentration be favored for the microwave growth. Means your syrup contains sucrose concentration, and you fix the concentration of the sucrose and use the required or fixed amount of sucrose in your formulation, because when you use maybe more concentration in your syrup solution or not solution formulation, so in this condition there may be chances that your syrup form crystals due to the high concentration of the sucrose. And if you use less quantity or less concentration of sucrose, and there may be chances of bacterial growth takes place, because it's also act as antibacterial when you use in large concentration. So both parameters are maybe affected formulation, large form crystals or less form bacterial growth, or maybe start bacterial growth or microbial growth. So there is no specific method for determination of the sucrose in syrup. We use HPLC and UV spectroscopy of this purpose. Means no any other methods you use for determination of this sucrose content or this sweetening agent content. Only some methods or some instrumental methods are used for this sucrose concentration determination, how much sucrose present in your syrup. So this is mainly used or check sucrose concentration with the help of HPLC and UV spectrum methods also. Next is physical stability in syrup. The syrup must be stable physically. Example, its appearance means it do not change their property, or it should be in a stable form, or don't show any layer separation or phase separation. So it should be in a stable form, and to check your syrup is physically stable or not. In this example, that you check the appearance, no crystallization, microbial growth is observed. Means you check by visual appearance directly, and with the help of the appearance, you can check if there is any crystal growth or microbial growth is present or not in that syrup. Next is color must be completely soluble with other ingredient. If you are using some color and the syrup solution containing some color, then your color should be uniformly distributed, or the syrup should be in a uniform color, and no uneven color is observed in your syrup solution. It's completely uniform color syrup. Next is odor and taste. They should be palatable. When from the starting point to their last expiry date, their color and taste don't get changed, and it should be in acceptable range or in a palatable range. And next is solid material is completely miscible in liquid. Means some solid material gets dissolved in a miscible liquid is not observed. So in this condition, you can say that your syrup isn't physically stable or don't show any stability problem. Next is evaluation of elixir, second liquid oral formulation or liquid dosage form. And you know that what is elixir? Elixir we already discussed previous lecture in very detail, or with the excipients and example of this excipients and what is elixirs, including the definition. So we just know about what is the elixir. And the definition of elixir: elixirs are clear, sweetened hydroalcoholic solution intended for oral use and are usually flavored to enhance their palatability. Means elixir is also a liquid oral dosage form, but it's a clear solution. Syrup may be contain more viscous, or it's not a clear solution, but elixir should be a clear solution and less viscous solution, and it's also sweetened in and taste, and it is mainly contain high concentration of alcohol or hydroalcoholic solution, or used for oral use, or maybe enhanced flavor of any formulation for the compatibility. So this is regarding the definition of elixirs. Next is evaluation parameters of elixirs. First is determination of alcohol content. In syrup, you see that a large amount of large concentration is your sucrose or sweetening agent in your syrup. Similarly, in elixirs, large concentration or more alcohol is present in your elixir. So first to determination of alcohol content in your elixirs. In this elixirs usually contain 5 to 40% alcohol. It's a too much amount of alcohol present in your elixir, that is 5 to 40% almost. Next is the determination of alcohol unless otherwise specified in this well monograph. These concentration of alcohol are specified or given in a particular monograph or specific pharmacopoeia or some standard book. So you check or use this amount concentration of alcohol according to some monograph, and it is suitable for examining most fruit extract like tincture and elixirs. Means you can say that these elixir is maybe used in some other formulation, or maybe for examining some another fruit extract like tincture and elixirs, or provide a capacity of distilling facts for sufficiently 2 or more times the volume of a liquid to be heated in this elixirs, and the rate of distillation is such that a clear distills are produced. When so there's too much heating this takes place in this or heat at least 2 to 4 times. Due to this, the clear distillation takes place and clear solution is obtained. And cloudy distill may be clarified by agitated with talc or with calcium carbonate. Means you require some clouded distillant or clarified distillation. In this, you use some excipients like maybe talc or calcium carbonate, and filtration is done after this distillation. And next is during oil manipulation, take precaution to minimize the loss of alcohol by evaporation. Means during this distillation process or distillation procedure, you're applying heat or you are heating too much. So take precaution or maybe take precaution or use a proper method that too much evaporation is not taking place, because if it evaporates a large amount, then more amount of alcohol that evaporate and the less amount of alcohol present in your formulation. And for liquid, it is presumed to contain less than 30% of alcohol. In liquid formulation, it is present approximately 30% alcohol concentration in excess. Next is viscosity measurements of elixir. Viscosity of elixirs is less compared to a syrup, and it's a thin solution when we compare with syrup. So you check viscosity of the elixir or formulation. In this, viscosity is a property of a liquid that is directly related to resistance to the flow. Means it directly proportional to the resistance to flow, how it easily flow. If it's more readily or easily flow, then their viscosity is less. And if it take more time, then it is maybe thick or more viscous solution. So viscosity measurement is an important quality control test in case of syrup and elixirs. We should know the viscosity of a particular formulation in both syrup as well as elixirs formulation. And viscosity and consistency directly relate to the stability of a solution. Means this viscosity or consistency of a formulation is directly proportional to or directly relates to the stability of a formulation or your solution. Viscosity increase, then there will chances increase in stability. Means you can say that if the formulation is more viscous or more viscosity solution, then it have a more stability or increase stability condition. It have a less stability problem if it's a more viscous solution, but if in less viscous, then the chances that more stability problem. So this is regarding the viscosity measurement. And you check the viscosity with the help of Brookfield viscometer or any other viscometer. With the help of this Brookfield viscometer, it gives accurate or correct results of viscosity. Next is evaluation of suspension. This is a third liquid dosage form or liquid oral dosage form that we check the evaluation parameter of suspension. First we covered syrup, second is elixirs, and now third one is suspension. So suspension is also a liquid dosage form. In this, pharmaceutical suspension is a post dispersion in which insoluble particles generally greater than 1 micron in diameter are dispersed in liquid medium and usually aqueous. The suspension itself says that some solid particle get suspended or dispersed in a liquid medium or in an aqueous medium, and the particle size is normally we can select a greater than 1 micron. Means more than 1 micron diameter particle you add in your suspension or liquid aqueous solution. When you add approximately more than or greater than 1 micron diameter particles, then your suspension is formed, and these are suspended or dispersed in a liquid medium. It's a definition of suspension. Now is the evaluation parameter or evaluation test for this suspension. In this, first is segmentation method. Segmentation method is evaluation parameter for only suspension, because the suspension is only contain solid particles or particles in your formulation. Elixirs and syrup don't have this particle. So the segmentation method is majorly used for check to the particle present in your suspension, or this test is for suspension. And in this, two parameters are studied for determination of segmentation. These are the two parameters that are necessary for determination of the segmentation rate or segmentation volume. In this suspension formulation, 50 ml was poured separately in 100 ml measuring. Means you take 50 ml of the suspension formulation or 50 ml suspension and These 50 ml suspension poured in a measuring cylinder, and the capacity of measuring cylinder is 100 ml. And after the cylinder sedimentation volume was reached after 1, 2, 3, and 7 days, and thereafter weekly interval for 12 weeks. Means you add 50 ml of suspension in 100 ml of measuring cylinder, and after adding into measuring cylinder, you check how much particle get settled down or sedimented after particular time. You just leave the measuring cylinder and record the readings for sedimentation rate of your suspension at every day 1, 2, 3, 4, like for 7 days. And after 7 days, you change the time interval to measure every week, or maybe take the sample, or not take the sample, but check how much particle get suspended or settled down in the measuring cylinder in every week. And this record of readings are you observe up to 12 weeks. And the triplet results were obtained for each formulation. Sedimentation volume was calculated according to equation. So at least check 3 readings or triplet reading is required. And it's the formula F is equals to VU divided by V0, where F is the sedimentation volume. V is the ultimate height of the sediment, and V0 is the initial height of the suspension. V0 means initial from starting first day, and V is the ultimate height of the sediment, and F is the sedimentation volume. It's a very simple method. Means you take a 50 ml suspension and add in a 100 ml measuring cylinder, and after adding into 100 ml measuring cylinder, you weigh how much, not weigh, check how much particle gets suspended in a measuring cylinder, and observe or note it down in every single day. And after 1 week, you observe after every week up to 12 weeks. For 12 weeks, and there's a triplet readings are required, and calculate the sedimentation ratio or sedimentation volume with the help of this formula. It's a diagram. If suppose it's a 150 ml measuring cylinder, you can take up to 100 ml measuring cylinder also. If you are taking large volume, then there's no problem. You are adding 50 ml suspension, and after that you again add 50 ml, then again 50 ml, and check how much particle gets suspended or it's still in a concentration. So F is 0.5, 1, and 1.5 in 150 ml. Next is rheological method. This is viscosity method, or you check viscosity of your formulation or rheological property of your suspension. And this viscosity of suspension is great important for stability and porosity of suspension. As no suspension have a least physical stability on all dosage form due to the sedimentation and cake formation. And so this rheological method is mainly for viscosity measurement of the suspension, and we should know that if when we compare all type of liquid oral dosage form, then this suspension have a very less stability, or it show more stability problem due to particle present in your formulation or in your solution. And these particles may be chances that form the cake or maybe settle down or sediment down. So this is problematic. So this test is mainly for suspension. And so that as the viscosity of dispersion medium increase, the terminal settling viscosity is decreased. Means when you increase or enhance the viscosity of dispersion medium, and in this condition, terminal settling velocity is decreased, and thus dispersed phase settle at a slower rate. They remain dispersed for a long time, building a higher stability to the suspension. And check how much particle gets sedimented. If you are not check properly this rheological property of suspension, then maybe chances that your sedimented solution get checked, or take the reading of the sedimented solution. And when you take the sedimented solution, there will be chances that your rheological property or rheology of your formulation get changed, because your formulation not in a proper uniform condition, or there may be chances that it's show some viscosity problem, because some particles are get sedimented, some are suspended in your solution. And in this, on the other hand, the viscosity of the suspension is increased, its porosity decrease. Means the more the viscous solution of suspension, or more viscosity suspension, as show more porosity problem or decreased porosity, and inconvenience to the patient for dosing increase. because the more viscous size show more pourable problem or not easily pour, and due to this some patient compliance is observed or some patient problems are observed, and the viscosity of the suspension should be maintained within optimal range to yield stable and easily pourable suspension. Means you should formulate your suspension in this type that it is easily poured and don't have too much viscosity or not too much less viscosity. It should be in according to requirement or according to stability. This is a rheological method of suspension. Now next in this practical rheological method involve the use of Brookfield viscometer mounted or happy bar stand. The T-bar spindle is made to descend slowly into the suspension and dial reading the response is then measure of residence stress spindle meter and meets various levels in sediment. Means this rheological property is measured with the help of Brookfield viscometer. We already previously said that for all type of viscosity determination, including syrup and elixir, use Brookfield viscometer. Similarly, for suspension determining the viscosity, use this same viscometer or Brookfield viscometer. And T-bar spindle shape is used to check the viscosity or dip in the suspension. It's a Brookfield viscometer that you use to check the viscosity of a liquid formulation, not only suspension, including the syrup, elixir, and all liquid formulation. And for semi-solid dosage, it is also used for checking the viscosity. Next is electrokinetic methods. Electrokinetic method for suspension. In this, zeta potential is measured by using micro-electrophoresis apparatus and zeta plus Brookhaven Instrument Corporation USA to show the stability of dispersed system. This zeta potential is also for suspension. In this, you check electrokinetic activity of your particles or zeta potential of your particles using micro-electrophoresis apparatus or zeta plus apparatus. Example of this electrokinetic method is micro-electrophoresis apparatus MK1. In zeta potential, that is zeta potential of the formulated suspension was determined by using zeta plus, that is Brookhaven Instrument Corporation USA. And approximately 1 ml of suspension was transferred into plastic cuvette using a pipette and diluted with the distilled water. And Brookhaven zeta potential software was used to measurement. The zeta potential of a formulation was determined on day 0-7, means every 1 week interval. It is a very simple method for suspension of determining the electrokinetics of your suspension or zeta potential. Means first you take 1 ml suspension solution and add this 1 ml suspension solution to a cuvette and dilute it with water. And after diluting, you take the reading with the help of this Brookhaven instrument. And you should set some specific condition like temperature is required 25 degrees Celsius and refractive index is 1.33. After setting this, you check how much changes takes place in zeta potential in every 1 week interval from initial starting 0 to 7, 14, 21, and 28 days for post formulation. So this zeta potential gives the reading of the electrokinetics readings of your suspension. Next is Micromeritic method for suspension. In this, the stability of the suspension depends on the particle size of the dispersed phase. Change in the particle size and reference to time will provide a useful information regarding the stability of the suspension. And change in particle distribution, crystal habit will be studied microscopy and quarter counter method. Means in Micromeritic method, you check the stability of the suspension or particle size present in a suspension or dispersed in a solution in dispersed phase. So change in particle size you check or provide the information regarding the suspension, and there's a 2 techniques that are used for this micromeritic determination of suspension. One is quarter counter method and another is microscopic method. This gives the all results or information regarding the particle size or crystal habit of the formulation. Next is photomicroscopic method. In this, microscope can be used to estimate the detect change in particle size distribution and crystal form. By using this, photomicrograph can determine a change in physical property and stability of a suspension. Means how much stability of suspension or change in particle size or the stability of organ check with the help of this photomicrometric method, microscopic method. Next test is freeze-thaw test for your suspension. This test is also for your suspension formulation. In this freeze-thaw test conducted by placing the sample in freezer for 18 hours, followed by thawing at room temperature for 4 to 6 hours, and repeat the freeze-thaw cycle for 10 times. And this test is conducted to determine the tendency to crystallize or color. This is a very simple test. In this, you put your sample in a freezer for 18 hours. After 18 hours, you remove your suspension from freezer and check temperature, throwing temperature, followed at room temperature for 4 to 6 hours. And after again, you put your sample in the freezer for 18 hours and repeat this cycle for 10 times. And after complete 10 cycle or 10 readings, you check how much changes takes place in suspension, maybe crystal formation is takes place or not, or it's in a stable form, or any color changes is observed or not. So you just put your sample in the freezer for 18 hours and repeat this cycle for 10 times. And after 18 hours, you check flow temperature, freeze thaw temperature in room condition, room temperature for 4 to 6 hours, and then check some crystal formation or crystal growth or color changes is observed or not in your suspension formulation. This is regarding a freeze thaw test. There's a machine for this freeze thaw test. Next is pH measurement. This is also similar to a syrup and elixirs. You check pH of your suspension formulation with the help of pH meter or with the help of pH paper, depending on the accuracy. In lab scale, you use a pH meter, a pH paper, but in proper accurate result, you use pH meter. In this, some measurement and maintenance of pH is also very important step in the quality control testing. Means it is a very important parameter when you check the quality of a suspension, using the measurement of the pH and method of pH measurement, and simple and cheapest to dip a piece of pH paper into the sample. With the help of a pH paper, you can also calculate the pH or check the pH of your suspension. When you dip the pH meter into a suspension, you show color changes, and due to this color changes, you can easily check how much pH of your suspension formulation. Next is visual inspection. Visual inspection is the name itself say that you check the formulation visually, or you check the formulation without any equipments. And in this, the ingredient and final product are carefully examined for purity or for appearance, how much pure of your suspension or how much purity of the suspension or any particle or foreign particle are present or not in your suspension. By the visual inspection, easily check. And physical appearance of your product for patient adherence and compliance is critical. So you should be good looking or elegance in appearance. Out of this visual appearance or visual check, you should then make sure that your formulation should be good looking or elegance of your formulation is also good, or appearance of your formulation within acceptable or elegance range. Next is evaluation of emulsion. It's another liquid dosage form or oral liquid dosage form that you check or evaluation parameter. So before starting this, definition of emulsion. Emulsion is a system consisting of two immiscible liquid phase, one of which is dispersed throughout the other in the form of fine droplet. In emulsion, you can say that is a two-phase system or containing oil and water as well as two both phase. And in this, you check how much particular dispersed phase or in the form of fine droplet. So we covered the first syrup, then elixir, then suspension, now emulsion evaluation parameter. In evaluation, first is determination of fine particle and particle count, how much particle size present and the number of particles present in the emulsion. In this, determination of a change in average particle size or size distribution of a droplet is important parameter used for the emulsion of evaluation of the emulsion. Means how much particle are present or average particle size, or how it get distributed, means particle size distribution in emulsion, or how much present in the formulation, or how easily it can distribute it. In this you check all regarding the particle size or distribution of particle in emulsion. It is performed by optical microscopy segmentation by using Adamson apparatus and Walter apparatus. These are the two apparatus that you use for checking the microscopy or segmentation rate of particle in your emulsion. And in this, next is determination of the viscosity. Similarly, viscosity is checked with the help of liquid viscometer for all liquid dosage form. For viscosity testing, use the Brookfield viscometer. It gave a good results. And determination of viscosity is done where the access to change might take place during aging. And emulsion exhibit non-Newtonian type of characteristics, and viscosity should be mimic on unplayed viscometer. Means in emulsion, you can say that it show non-Newtonian type of flow or non-Newtonian emulsion. So there may be chances that viscosity has changed, and after storage of particular time period or after store for a particular time, you check how much viscosity has changed or it's unstable or not a stable form. You can use Brookfield viscometer, or instead of Brookfield viscometer, you can also use this cone and plate viscometer. It is also a viscometer that is used to check the viscosity of your emulsion. Next is determination of phase separation. Emulsion containing two phase or oil and water phase. So for this emulsion, you should check the phase separation property of emulsion also. They are stable form or not for particular storage or particular time period. And then if there's a two-layer art form, then it may show a stability problem or stability issue. So this phase separation condition is also checked for this emulsion. And this is another parameter used for assessing the stability of the formulation. Phase separation may be observed visually by measuring the volume of separated phase. And after storage or after a particular time period, you check there's a layer separation that takes place or not, or two phase volume is observed or not. Visually, if there's a two layers get separated, then there may be chances that your formulation or your emulsion is not in a stable state. This is a problem or flocculation problem in the emulsion. First is coacyls, second is flocculation, and third is creaming, and fourth one is breaking. If this type of flocculation or emulsion is observed, then you can say that your emulsion is in good quality or should be in a stable condition. If you observe this type of emulsion, maybe creaming on the upper surface or maybe breaking like this type, or flocculation between the particles or coacyls. So this four conditions show that the emulsion should be in a good condition and don't have any problem or having stability issue. Next is determination of electrophoretic property. This is also for emulsion, and this is check electrophoretic property of the emulsion. And determination of electrophoretic property like zeta potential is useful for assessing flocculation since electric charges on the particle influence the rate of flocculation. In this check with the flocculation rate of your formulation or zeta potential of your formulation. There's any electric changes as takes place or not in your formulation of flocculation property. In oil and water emulsion, having the fine particles will exhibit low resistance. Suppose your formulation is OW type, and in this condition, the fine particles will exhibit or maybe exhibit low resistance, and particle size increase that indicate a sign of oil droplet aggregate and instability. Means particle size get increased, then it may be show fine particle droplet or aggregate formation, or it show instability problem and show in a stable form of emulsion. This is regarding the electrophoresis property. So these are the all parameters regarding emulsion or evaluation parameter of the evaluation. After completing this topic or this lecture, you should know about this outcome. Brief introduction about evaluation of a liquid dosage form. Means how to evaluate your liquid dosage form, including all liquid dosage form, the classification and evaluation parameter, which parameter is appropriate or suitable for which type of formulation, including syrup, suspension, emulsion, elixirs, because we already covered evaluation parameter of syrup, then elixirs, then suspension, then emulsion. So you know about the complete information regarding this liquid oral dosage form, and the definition, ingredients, and the procedure for evaluation and formulation, and which test to perform for that particular formulation. Suppose you are preparing syrup, then which tests are required, and for emulsion, which tests are required, because every formulation have a different test. Only one or two tests are similar for all liquid dosage form. Otherwise, every liquid dosage form should have different tests for evaluation. So you know about brief introduction of this evaluation of a liquid dosage form with the evaluation parameter, including procedure of this evaluation test and which test is more appropriate and good for that particular formulation. So this is regarding the learning outcome. After this learning outcome, these are the reference for this topic. And pharmaceutical dosage form, drug delivery system. Eighth edition by Louis V. Nicholas, G. Popovich, Howard C. Ansel, published by BI Publication Pvt Limited. The first reference. And second reference, Pharmaceutical Pre-Formulation by Jetty Cartesian, published by Technological Publishing Co. And third reference, Textbook of Physical Pharmaceutics by C.B.S. Subramania, published by Balla Prakashan. Next reference, The Theory and Practice of Industrial Pharmacy by Leon and Lackman, Havas, Lieberman, Joseph, L. King, third edition, published by Legacy Publishing House. And next fifth reference is Martin, Physical Pharmacy and Pharmaceutical Science, fifth edition by Patrick J. Sintu, published by Lipperford, William and Wilkin. This is the reference for this liquid dosage evaluation parameter. All references are good. You can use any one of the book or in all books or combination for better content or better matter. So next is the question part. This question are related to a liquid dosage form or evaluation of a liquid dosage form. And today we complete this topic or liquid dosage form, including complete the information from starting the introduction to evaluation parameter, including procedure, formulation, excipient with the example, evaluation parameter. All this we covered in this lecture, including previous lecture. So this is the question part for liquid dosage form. In this first question, these properties include odor, appearance, and taste of the use and properties of excipient that drug more patentable. A is an optical counting method, B is a hot stage microscopy, C is segmentation technique, and D is an organoleptic property. If you know about liquid dosage form or evaluation parameter or physical chemical property of this liquid dosage form, you can easily answer this question out of this ABCD option. In this question, we discuss about color, odor, appearance of your liquid dosage form, or how this excipient change the property of a liquid dosage form. In next second question, these are the more precise method for determining melting point, that is measure phase change in qualitable data. Means in this you check which answer is correct according to melting point, or when you check the melting point of your formulation. In this, A option is organoleptic properties, B is DSC and DTD. C option is equilibrium solubility method, and D option is segmentation technique. These are the four technique or four option for the determination of liquid dosage form. According to appropriate melting point or phase change method, you can select any one of out of this ABCD correct method or correct option. Next is third question, the solubility of unionized parent compound. A option is optical counting method, B is equilibrium solubility method, C is intrinsic solubility, and D is organoleptic property. In this third question, mainly we discuss about solubility of unionized compound or unionized parent compound, and there's a fourth option. And next fourth question, this method can be measure particle size below 1 micron, or most exact method covered by measuring how well a particle passes through a laser beam of scattered light. This question is regarding the particle size. The particle size is less than 1 micron or up to 1 micron, then which method is used for determination of this particle, or scattering method for exact particle size determination, or by the help of laser beam scattering light. There's four options. In this, A option is laser diffraction method, B is bulk characterization method, C is electric counting method, and D is segmentation technique. So according to this question, or according to particle size, you can select any one correct answer out of this ABCD option. Now next question is fifth question. In this fifth question, which property measures the resistance of a liquid flow? Means in this related to flow rate or property for checking the particular flow rate or resistance of the flow rate. In this, A option is density, B is viscosity, C is volume, and D is solid. These are the four properties. You can select any one property according to, or maybe depend on the liquid flow rate. And next sixth question is, what is the correct definition of a pseudoplastic liquid? In this pseudoplastic liquid, what definition of pseudoplastic liquid and what is pseudoplastic liquid. If you know definition and information regarding pseudoplastic, then you can easily answer this question out of this four ABCD option. And now we see the option. In A option, a liquid which becomes less viscous as the rate shear increase. B is a liquid which becomes more viscous as the rate shear increase. And C option is a liquid which becomes less viscous over a time when a constant shear stress is applied. And in D option, a liquid which becomes more viscous over a time when a constant shear stress is applied. Next is seventh question. In seventh question, the stability of emulsion, which important and stability steps should be prevented. And this question is regarding the emulsion. We already discussed the evaluation parameter of the emulsion, so you can easily answer this question or answer out of this ABCD correct option. This is regarding the stability of emulsion and which parameter shows the stability problem. And in this option A is breaking, B is quiescence, C is flocculation, D is cleaving. These are the four options for emulsion. According to this, you can select the any one correct option. Eighth question is Brownian movement of a particle in suspension cause. In suspension, we already covered the Brownian movement or suspension evaluation. So you answer this question for suspension according to the Brownian movement. In this, A option is assist segmentation, B is promote segmentation, C is prevent segmentation, and D is increase segmentation rate. So you answer any one correct answer for Brownian movement of suspension. Next is ninth question. What is the role of xanthan gum within a liquid formulation? So in liquid formulation, xanthan gum is used, and you know about what is xanthan gum. If you know this xanthan gum, then you answer this question, or you can select any one correct ABCD option for liquid formulation. Xanthan gum role in this option is regulate pH, B is control viscosity, C is enhance solubility, and D is enhance viscosity. So it's a ninth question now. Last 10th question. In this, which of the following statement is false? In this, A option is liquid formulation for intravenous delivery must be aqueous solution that do not precipitate in the bloodstream. This is a option. In B option, parenteral suspension, oil-based parenteral solution can easily be administered by intramuscular subcutaneous route. And C option, small volume parenteral liquid must be administered intravenously, but large volume parenteral liquid must may be administered by any other route. And last, D option, water for injection is term used to describe sterile purified water that is reserved for preparation of aqueous medicine for parenteral delivery. Means out of this ABCD4 option, you can select any one correct option which have a false statement and not a correct statement for liquid dosage form or liquid or oral formulation. So this is the question part of this liquid formulation. To answer this question after completing this topic. So thank you so much for watching and listening this video. Thank you.